equals 0. Why is that?
Wait a minute. What is the question number? 6 point.
6.6.
What is the question?
Why it's written Z2 equals 0? What is written in the question?
Z2 is he has taken on the lower side, right?
Yes,
So Z2 is 0 because it
because
is reference.
it's connected with the line, right?
No, I mean, you have to take the difference between the two. If you take one as 0, the other will be the difference between the two. So,
Okay.
so 2 is the reference here, and the point 1 will be there. Z1, the height difference between the two levels.
Yes, he wants the question wanted to Z1. How much is Z1? And then you check the difference,
Yes,
right?
and Z1 because the slope is given
Yes,
1 in 30.
yes,
So based on the 1 in 30 means in 90 it will be 3 meters, right?
right.
So it will be slightly more than 3 meters. It will be 3.33 meters.
Yes, yes, that's right. And I have another question in problem 6.10.
6.10. Okay. Yes.
Uh, the y here is the unit of the area, and the diameter here is in centimeter. I solve it with the meter, but the answer in the end is different. The same number, but the point is not the same. Like the area, it's
So you got
700.6, 706.
0.125. 1 minute. You got answer 0.125.
What? Yes, yes, yes.
So yours is correct. Meter cube per second.
Yeah, but
It,
I mean in the solving way, should I change from centimeter to meter, or it's okay?
no, actually, if you see he has done a mistake. In the under root 2gh, he has taken 2 into 9.81. Here he is taking acceleration in meter per second square and multiplying with centimeters 252.
Oh, okay, okay, okay.
So
Also,
actually,
yes,
if you
yes,
see other places, he has taken 981 for the G. If he's
yes.
taking
This is also one of the questions that I want to ask.
yes,
Why,
if
like
he is taking
under the
centimeter everything,
square is 2 over 901,
2
but
multiplied
here
by
in the
91.
question is 9.81.
Yes, if you are taking everything in meter per second, it should be 9.81.
Okay.
And if you are taking everything in centimeter, like in question number 6.11, you have to take 2 into 981 into 400. So in
Uh-huh.
question number 6.10, he did mistake. Uh, that 9.81 he has taken in meter and other values in centimeter. That is not correct. The answer is correct. Final answer is correct.
Okay, but the solving way is not.
Yes. We solved this problem in the class, right?
Yes, that's right.
I told that day as well, this one. This
Yes, I
problem.
know. Yeah, yeah, right. Also, another question in 6.11,
Yes.
the CD in the question is given 0.98,
Yes.
but after using the question, the equation of 6.8, he used CD as 9.18.
What? No.
He used
Nine.
it in the CD. It's given in the question 0.98. That's right.
Yes.
Okay, but in the solving way, if you go down like after the Q equal like 60 into 1000 equal 9.81. So why he changes like that?
You are
I don't,
talking about 6.11.
yes.
I cannot see.
6.12. Sorry, 6.12. Sorry.
Yes, it is printing mistake. It should be
Printing mistake.
0.9. Yes.
It should be 0.89.
98.
Yes, 98. Sorry, 98. The same is given in the question.
Yes. Yes.
No change. Okay, so
Yes.
it's just printing mistake.
Yes.
And but I didn't get the same answer, doctor.
You try again, you will get, inshallah.
Okay, I will try it and send it to you. Okay.
Okay.
Okay, no problem.
Okay, what we discussed in the morning class, it was related to the flow through pipes, right? So inshallah, I will compile chapter 3 already sent, right? Chapter 4 I will compile and send.
Doctor,
Yes.
can I request something from you?
Yes.
Uh, it's you know
Yes.
what do you think if we just let chapter 3 for the next quiz, because
The,
chapter 3 is a little bit long, you know.
see, your course is actually the combination of two subjects, fluid mechanics and thermodynamics. We have not started thermodynamics yet. So we may have, otherwise we may have more number of quizzes otherwise. So
But chapter 3 and chapter 4 is going to be long for studying.
chapter 4 is a short one, right? Not very much.
Okay.
So it will combine, if we combine it.
No problem. Thank you, doctor. Thank you so much.
Okay. So we are studying flow through pipes. We said if we have laminar or turbulent flows, then we can have the, whatever is the type of flow, we have losses, and how to calculate the losses we have discussed. Now if the flow is turbulent, okay, we can divide the losses into two categories. That is, one is called as the major losses, and second one is minor losses. Okay, major loss is HF, that is head loss due to friction. We know this HF is 4FL V square over 2G. Whereas minor losses are related to the, say, the loss while it is entering inside the, at the entry, at the exit, or when there is a sudden expansion. or contraction, or if there is any bend in the pipe, or if there is any obstacle in the flow. Okay, so these are the different conditions. See, this was the straight pipe, right? In the case of major losses, it was based on the surface and flow and fluid properties, right? Okay, considering the flow and fluid properties, we discussed that we have the major loss due to the friction. Now, if we have, say, for example, sudden expansion, like, for example, if you see this, what is happening here? The flow which is coming like this will go suddenly like this, and there may be some recirculation here. So this is the basically there is some loss of flow. So the flow which is coming here will not go forward easily. It will recirculate and then will go. So we have some loss of energy here. The momentum is now lost. Okay. So this is called as like loss due to the sudden expansion. Similarly, for example, if you have a sudden contraction, then what will happen? It will go like this. The flow will be like this. Am I right? Do you think that the flow here will go, try to go in, can get the any chance? I know that you do this in the while driving. Whenever you have the narrow passage, you try to go this way, right?
Yes, that's right, doctor.
You don't follow the lane. Okay, but here in the flow it's not like that. Usually this flow which is central will try to go in the narrow passage. This will be like there all the time. So anyway, so we have losses due to the contraction. So this is like expansion, then contraction. Contraction means after a large area you have a sudden small area, then there will be loss. From small area, if you have a large area pipe, then you have the losses. You can imagine the inlet as the sudden contraction. Okay, because usually the inlet, the water is coming from the large tank, right? So in that case, it will come like that. Exit, it's like expansion. It is coming from narrow passage and going to the atmosphere or large area. Is that clear?
Yes, doctor, yes.
Bend means, say for example, if you have a bend, the forces exerted we studied, but there will be some losses. If it is straight, there will be no losses, but if it is bent, there will be some losses. Okay, so what I will do, I will try to draw the figure and write the equation for minor losses. Minor losses are usually neglected, but if you want the clear picture, you can add the minor losses with major loss. Okay. So what are the different minor losses we have? So we'll start with the sudden expansion. Sudden expansion. So flow will be like this. If I apply the continuity Bernoulli equation or energy equation at 1 and 2, the area at 1 is A1 and area at 2 is A2, or velocity is V1, V2. Then the head loss due to expansion, HE due to expansion, is equal to V1 minus V2 whole square divided by 2G. Please write down this. Then we have sudden contraction. HC contraction will be equal to V2 square divided by 2G. Sorry, equal to 0.5 V2 square divided by 2G. Half of the kinetic head, half of the kinetic energy can be lost due to the contraction. Third, at the inlet, so HI will be again 0.5 V square divided by 2G. At outlet, HO will be equal to V0 square divided by 2G. That is the outlet velocity. You can say this is the inlet velocity.
Doctor, what is inlet and outlet?
Inlet, say for example, if there is a pipe, it is coming from, there is some inlet, right?
Yeah, inside the pipe.
Yes, this is the outlet. When the
Oh, okay.
when the liquid is entering, when the liquid is going out.
Okay. So
From-
that
From
the
it may be
yes.
directly coming from the some other pipe, or directly coming from the say atmosphere or any place, okay, or from reservoir. So it is coming from the other place, right? So it is same like contraction. It is coming say from the big to small. Whereas this is like is from small, it is going to the main outside, which is very large. Imaginary.
Yes,
So this
yes.
is inlet and it's outlet, simply.
Yeah, and the also the laws will be different, not the same.
Not same. So if there is any obstruction, so you need to know the velocity at the obstruction square divided by 2G. Obstruction means, say there is a pipe and there is something inside the flow. Okay. Some object is there, like some wall, etc. is there. Okay. So this is obstruction to the flow. So you need to know the velocity here, because how much area it is blocking. If it is blocking the larger area, then velocity will be higher, because if you see it, if it blocks large area, then the passage through which flow is going, it will be smaller. So area will be smaller, and it is like nozzle. You might have tried keeping your thumb or finger in front of water jet. So you will find the water from the other place will try to go at higher speed, right?
Yes, right, doctor.
So these are the minor losses. There is also one loss due to the bend. So I'm writing here. You write after this, after the obstruction, write this 6-1 due to the bend. And this loss HB is equal to K into V square divided by 2G. Velocity near the bend and K, where K is a factor, depends on the area and how bending angle. Say if the bend angle is 10 degree, then less losses will be less. But if the bend is say 90 degree, then losses will be high. If like 135 degree, then it will be again high. So the losses due to the bend will depends, this K depends on the angle and other properties. These are minor losses.
Doctor, I have a question, please.
Yes.
What is K?
K is a factor, constant. It depends on the angle of bend.
So
Like it can be 0.5, it can be 0.2, it can be 0.8. Say for example, it can be 0.8 if 10 degree is the angle, but it will become like 0.5. That means more losses if the angle is high.
so it depends on the angle,
It depends on the angle and other properties.
and it will given in the question, or should I find it
Yes, yes,
by
yes,
myself?
Okay.
Okay.
I have sent you a question in the WhatsApp group. Can you read that question? It is related to the minor losses. Major plus minor loss. Okay, finish this one. Can I erase this?
Yes, yes, doctor.
Yes, doctor, yes.
Or if you're not finished, take the screenshot and you can save it for your.
Doctor, can you tell us which problem you send in the group, the number of the problem?
I just sent the screenshot. Can you see?
Yes, 11.68.
In the WhatsApp group, yes.
The 11.16 is the question number. If you read this, it is given determine the rate of flow of water through the pipe, through a pipe of diameter 20 centimeter and length 50 meter, when one end of the pipe is connected to a tank and the other end of the pipe is open to the atmosphere. The pipe is horizontal and the height of water in the tank is 4 meter above the center of the pipe. Consider all minor losses and take F equals to 0.009 in the formula HF equals to 4 FLV square 2 GD. Now, if I have a tank, pipe, and then exit flow, do we have any expansion or contraction here?
I think expansion.
Okay, I will draw the figure, then it will be clear to you. See, there are no two pipes, only one pipe is there, right?
Yes.
So if it is only one pipe, then it will be like entry and exit only. If the flow is going from one pipe to another pipe, then you can say contraction or expansion will come. Are you getting that?
Yes. Yes.
If you have read the question, please tell me the values. So there is a tank. And this is say full of water. Is it mentioned water? Okay. And what is the length of the
Yes.
pipe?
50 meters.
50
50,
meters.
50 meter.
50 meters is L.
And the diameter is 2 centimeter, 20 centimeter.
Diameter is 0.2 meters. The height of this water level from the center of the pipe
4
is
meter.
4.
4
4.
meters. Okay. Say if I take this as the first and this as second, okay, or this is as first or second, doesn't matter. Okay, you can take it.
Doctor.
Yes.
I understand from the question, there is a pipe goes into the tank, another pipe goes out.
Yes.
That's
So
what.
the pipe is connected on one side, it is connected to the tank, one side it is connected to the atmosphere.
No, I understood from the question.
Yes. What
Two
you understand?
pipes, not one.
What?
I understood. There is two pipes.
Read it. Read again. Okay, read loudly so that everyone can understand.
Yeah, okay, I found it. When the one end of the pipe is connected to tank and the other end, yeah, that's all correct.
Going to the atmosphere, right?
Yeah.
So if I apply the P1 by rho g plus V1 square by 2g plus Z1 equals to P2 by rho g plus V2 square by 2g plus Z2 plus, yes, losses, all the losses. What are all the losses? You can take at the entrance, okay, plus HF, okay, at the inlet and head loss due to the friction. You can add head, if you want, you can add head loss due to the exit as well. But if it is going to the, say, tank, then you can say it is exit. Say, for example, if it is like this, okay, then you can also use for the exit. Here also, if you want, you can add to the exit as well, but we will consider this as the only inlet and friction. Okay, because we are considering this point, right? So here we have the inlet and kinetic, 1 and 2. Now, please tell me what is P1? Pressure at 1 is atmospheric
Atmospheric
pressure.
pressure.
Okay. We are already considering the this Z1 and Z2. These are basically the that water head only, meters of water, right?
Yes.
So P1 is 0 plus V1 is also 0 plus Z1 is 4 equal to P2 is 0, or you can say both are like atmospheric pressure, because already the hydraulic pressure we are already considering. V2 is not 0 because V2 is flowing, right? It is going to flow. Okay, here it is not flowing. Here it is flowing. So V2 is square by 2G plus Z2 is 0. Okay, if you are taking the from here, what is the difference between Z1 and Z2? It is 4, right? So 4 minus 0. If I take this as reference, this is the difference between the two is plus, what is the head loss at the inlet? 0.5 V2 square by 2G. Am I right? Plus HF. What is HF? 4 FLU square by 2G. So if I separate this, 4 equals to, this is 1, this is 0.5, so it will become 1.5 into V2 square divided by 2G plus HF is 4 into F. What is the value of F? 0.009, it is given. Do we need to check whether it is laminar or turbulent? We don't need to check because F is already given. That formula is for the turbulent, right?
Yes.
So 4F into L. L is 50. 4F LV square, that is V2 divided by
D
2GD, right? So 2 into 9.81 into
0.7.
0.2. Now what is the only unknown here? V2. Can you get V2?
Just a second.
So instead of G, I am writing 9.81.
Doctor,
Yes.
should we have used the formula or the equation that says HF equal 4 into F into L into F square over D into 2G?
We use
Find
that one.
V. Oh, okay.
4 FLV square.
Yes, 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 that's right. Yes, yes, yes. Okay, okay.
I got
Sorry.
2.733.
V2 is 2.739.
733. 9.
meter per second. Now we need to calculate, it is asked to calculate the discharge, right? How much is the discharge? So how to get discharge? Area into
Velocity.
velocity. Pi by 4, 0.2 square into 2.733. See, I will not take the name, but one student has calculated area as pi by 4 d. He has not taken the square in the quiz. One student wrote the unit of velocity as meter square per second. These are minor mistakes, but you should be careful. See, because of this, he got the wrong values. I gave the mass, but you should be careful with these minor mistakes.
Yes.
Yes, doctor. Thank you.
For this charge, I got 0.085.
0.085
Yeah.
meter cube per second. Okay. Okay, can you solve some other problems related to the minor losses from the book?
Yes, inshallah.
Because it's not worth repeating the questions. Because this, as of now, we have not studied any difficult things. We have studied only simple things only.
Straightforward.
Yes, straightforward, formula based. Let's see, we'll discuss this. Pipes in series. So now whatever I'm discussing, we are not considering the minor losses. We are considering only major losses for this discussion, I'm saying. Okay. Some problems related to the minor losses, please try to solve yourself. Anyways, I'm going to compile the questions as well. Now say what pipes in series. For example, if I have a tank and from this tank we have say 3 different pipes we have. Okay. Okay. Now, this is, say, it has length L1 and diameter D1. The second pipe has length L2 and diameter D2, L3, D3. See, I have drawn like small, big, and then slightly smaller, but it can have any diameter. You can have continuous expanding or continuous reduction as well, like this. You can have 3 pipes in this direction reducing, if you take in this direction, and continuously increasing. So what do you think in this? Say F1 is the loss, F2 is the loss, and this is the F3. This F1 will depend on L1 D1, right? F2 depends on the sorry, F1, F2, F3 are not dependent on L1. The HF will depends on this F1, this L and D1. HF2 will be depend on. So the total loss HF will be equal to HF1 plus HF2 plus HF3. Am I right?
Yes.
Okay. So loss is coming same, right? How about discharge? Discharge will, whether it will be like this, that Q is equal to Q1 plus Q2 plus Q3. Is this correct? That total discharge is equal to discharge from 1, 2, and 3.
No, doctor. No.
Why?
Q3 equal.
Q1 is equal to Q2 is equal to Q3.
Yes, exactly.
Yes.
Because discharge is going to be same, right? We know that. Continuity equation. Because whatever is going from here is same mass here and the same mass here. Only velocity and area is changed, right? So Q is equal to Q1 is equal to Q2 equals to Q3. Is this clear now?
Yes,
Okay.
doctor, it's clear.
Doctor, how is equal each other and areas different? Or
Because
diameter?
velocity will change.
Sorry?
Velocity will change.
Also area.
Also area is changing. Yes. See, Q is equal to A1 V1
V1.
equal to V2 V2, right? Equals to A3 V3. So area is, say for example, increasing, then velocity will decrease. If area is decreasing, velocity will increase, but their products will going to be same.
So the resultant will be same. Yeah.
I mean, it is same, not resultant. It is the same.
Yeah, yeah. Yeah.
At any location, it is going to be same.
Yeah, yes, yes.
Okay. Okay, I will just for make it clear, I am giving you another example. This is that I will explain later. Say for example, I have a one pipe. We discussed this as well already in chapter 3. Now, say this is 2, this is 3, and this is 1. Now whether Q1 is equal to Q2, Q3, is it like this?
No.
No,
No.
doctor, no.
No.
There it will be Q2 plus,
Q3.
Q3.
Yeah,
Yes.
because the mass has divided into two.
right? Is it the
Right.
case here? No, right?
No.
Okay. So this is called as branching. This is pipes are in series.
Okay.
Now, what is Q equals to? Or Q is equal to area is pi by 4 d square into velocity, right?
Yes.
And what is velocity for from this? 4Q divided by pi d square. Am I right?
Yes, doctor.
Okay. Now take f is equal to f1 is equal to f2 equals to f3. Value of f is same in all three. Okay, assume this means assumption. So because the same fluid is going, so viscosity etc. will be same. So and Reynolds number will not change much. So considering f1 equals to f2 equals to f3, what we can write? Say what I want to do. My aim is to get a pipe of diameter such that instead of three different pipes, three different size, we have three different here, right? So I want something which is like the equivalent to this, that instead of three pipes, I want one pipe which will give me the same discharge and same loss, total loss. Are you understanding this point?
Yes.
Instead of three different pipes pieces, I want to connect only one pipe.
Yes, like equivalent one.
Yes, this is called as equivalent pipe. Equivalent pipe. Then remember V is equal to 4Q divided by pi d square. So HF equals to HF1 plus HF2 plus HF3. So 4FL V square divided by 2G D equals to 4F1 L1 V1 square by 2GD 1, right? Plus 4F2 L2 V2 square by 2GD 2 plus 4F3 L3 V3 square divided by 2GD. Am I right?
Yes, doctor. Yes.
Now I can cancel 4 from every place.
Yes.
Yes, doctor.
F is equal to F1 equals to F2 equals to F3. So 4F2G will be cancelled, right?
Yes, doctor.
So this will become L into what is V? 4Q divided by pi d square, right?
Yes. Over.
Velocity is equal to, see, Q is equal to pi by 4 d square into velocity, right? So velocity is equal to 4Q divided by pi d square.
Doctor,
Yes,
why we don't write it as Q over A?
because I need equivalent pipe diameter.
Okay.
Diameter of the equivalent pipe. Okay. So divided by
D.
D. Okay. It is equal to L1 into 4Q divided by pi D1 square whole square divided by
D1.
D plus L2, this 4Q divided by pi D2 square whole square divided by D2, and same thing L3 4Q divided by pi D3 square whole square divided by D3. Okay. What can I cancel now?
The 4Q and pi.
4Q and pi squares will go down, right? So what will remain here?
1 over the square.
Its square is also there, right?
Yes. So it's 1 over the power 4.
Power 4, and here it is 1. So it will become d2 to the power
5.
5. Are you getting this? See this, 4q, 4q square, 4q square, 4q square. You can take common and cancel. Pi is gone. Pi is gone. Here 1 divided by d squares is square. So this will be 1 divided by d raised to 4. Okay, I will write one step. It will be like 1 by d square, right?
This.
Can you hear me?
Yes, yes.
Okay, so d square is square. So can I write this as 1 over d raised to 4?
Yes.
Okay. Now this is in the denominator. This is also in denominator. So what it will become?
1 over the power 5.
L over d raised to 5. Okay. And here it will become d raised to 5, d2 raised to 5, d3 raised to 5. All will get cancelled. So what is the equation coming? For same length, L over L1, L over d raised to 5 is equal to L1 d raised to 5 plus L2 divided by d2 5 plus L3 d3 raised to 5. I wrote here for 3 pipes. Can I write for 4, 5 pipes?
Yes, yes.
Yes, any pipe, right? But remember, what will be L equals to? L will be equal to L1 plus L2 plus L3. Total length.
Yes.
Okay, so please write down this. What is the equation coming for the equivalent pipe? This is the equation. L by d raised to 5 equals to L1 over d1 raised to 5 plus L2 over d raised to 5 plus L3 divided by d3 raised to 5. Where L equals to L1 plus L2 plus L3. This is when I want an equivalent pipe to replace the multiple pipes of different in series, different sections of different cross section area pipes, but in series. If it is in series, then only I can
Add them.
So for example, if I ask in exam, you can easily do this, right? It's not that difficult. Okay, let's do some problems related to the pipes in series and for this equivalent pipe. Let me share the screen. You have written whatever was written on the board.
Yes, yes.
Okay, let's solve question number problem 11.30a. It is same 11.30 and 30a.
He didn't say here whether it's horizontal or vertical, right? Or inclined.
It is given that the difference of water levels is 16 meter. Okay, so at least you need to show the difference of levels. Okay, whether the pipes are inclined or horizontal, it doesn't matter. Okay, difference in the level you need to show, whether you are showing the pipes inclined or horizontal, it will not affect.
Okay.
Yes, sir. Completed your drawings?
Yes, doctor, I draw it, but I don't know if I'm right. I mean, I'm true or not.
Okay, I will show you on the board, then you can check and then you can discuss.
Okay, doctor.
Okay, can you see the figure on the board? You can have the horizontal pipe as well, no problem. But
I
you need
draw it as a horizontal, but without the last tank.
because it is written there that the difference between the tanks.
Ah, okay. So I just miss the last tank. I didn't draw it.
No problem. Okay.
I did it horizontal, and the second one is
See, if you are
16.
not drawn the, then how you know how you will show this 16 meter, the difference between the height, the level difference.
You mean in
Um,
horizontal?
No. See, if you are drawing horizontal, what you have to do? You have to take two tanks and show this difference. level of the difference.
Yes, that's what I did.
If you have drawn like this, then also it is correct, but you have to show the difference in the levels of the heights. Okay.
Okay.
Yes, any other questions?
Doctor, can you share the question in the group, please?
Yes, yes. Sir. You want now or later?
Later, it's okay.
It's already
Just-
booked with you, right? So you can even take 11.3.
If you give me the number, it's okay of the question. It's enough.
Yes, 11.3 I told, right?
It's 11.13.
30A.
30, right?
Yeah, 30A.
Okay.
Okay, that's why I shared that. Okay, anyway, so how to do this now?
Find the equivalent. Five.
F1 and F2 and F3 is equal 0.005.
No, we don't need to find the equivalent. We need to find the discharge. Velocity is not given. Velocity is not given. Discharge is not given. See this. First of all, you apply the energy equation at two locations. Okay, and find out the HF. Okay, so it will be like this: P1 by rho g plus V1 square by 2g plus Z1 equals to
P2 over rho G
P2 over rho g
plus V2 square over 2G plus Z2 plus HF.
HF. Since these are the tanks, so the velocities and pressures will be 0. Okay, P1, V1, P2, V2, 1. What it will be HF? Z1 minus Z2.
Z2.
How much it is? 60 meters of water. No, what is HF equals to?
For turbulent? Oh,
Yes, of course, turbulence it is, right? It's not 4 FLV square dy,
2GD. Audio.
right?
Yes.
Plus 4 FL V2 square divided by 2G D2 plus 4 FL V3 square divided by 2G D3. If you remember V1 we kept in terms of Q, 4Q divided by pi D1 square, right?
Yeah.
Okay. So can you just keep it and calculate it? We are not going to calculate the equivalent. We want what we want? We want Q. So it will be equal to, if I keep, see, if I keep what V equals to, remember, 4Q divided by pi D square, right?
Yes.
So what will be V square will be equal to 16 Q square pi square D raised to 4. Okay.
Okay, doctor.
So instead of v square, we will put that. Then if I put that 16 into 4 will be 64 f. This is L1, L2, L3. Q square divided by 2G. This will be common from everywhere. 64 F Q square divided by pi square into 2G will be common. So what will remain here? L1 divided by D1 5 plus in this it will remain L2 divided by D2 raised to 5 plus L3 divided by D3 raised to 5. Now L1, L2, L3 given, D1, D2, D3 given, 64 is there, F is given 0.005, pi square into 2G into, now what is HF? HF is 16. So what is unknown here?
Q square.
Yes, Q square is unknown. So you can get Q from this. Please put the values and try to get the. Remember, V is equal to 4Q divided by pi D square it was. So if I take V square, it will become 16Q square, pi square and D raised to 4. So instead of V1 square, I can write 16Q square divided by pi square D1 is raised to 4. So D1 raised to 4 and this D1 will become D1 5. 16 into 4 will become 64. F is there. Okay. L1 and then D1 raised to 5 will be separate. All other things will be can be common, taken common. Okay. So please use this and calculate the value of Q. Have you understood this or should I explain again?
Doctor, D1 to the power 5?
Yes. See, 4 is here, right? And 1 was already there.
Yeah,
A raised to m plus into a raised to n will be equal to a raised to m plus n, right?
yeah, the sum of them, yes.
We have many students absent today still.
I got 0.1108.
Meter cube per second.
Yes,
Have you taken the square root later?
yes.
Let me check what is the answer in the book.
In the book, it's 0.08, so it's near for me.
In the book, it is 0.1108. You said that only, right?
I said 0.1108.
Yes, it is same in the book.
In the book, it's only 108, not 1108.
If you see the page number 5086, it is 0.1108. You are looking actually the second case, that is the including minor losses. If you see the first line of 506 page number. Okay, I can share.
Oh yeah, I saw it. Sorry about that. So it's the same, yeah.
So he has done some complex calculation than ours, because he calculated velocity first, then calculated discharge. But I think it is better to calculate discharge first and then velocity. Now you have discharge, so you can get V1, V2, V3 easily, right? Because diameters D1, D2, D3 are there.
Yes.
Okay, so we will neglect the minor losses in the series pipes. So we solve this some other numerical related to the equivalent pipe. We will not consider the minor losses in the series problem, remember.
Okay.
Okay. Okay. Now 11.31.
11 point how much?
31. I'm sharing on the screen. Can you read this question on the screen?
Yeah.
Yes, doctor. Yes.
Yes, yes, clear.
3 pipes of length 800 meter, 500 meter and 400 meter and of diameter 500 millimeter, 400 millimeter and 300 millimeter respectively are connected in series. These pipes are to be replaced by a single pipe of length 1700 meters. Find the diameter of this single pipe. Okay. So we got one equation for the equivalent pipe. Like what is that equation? L over
D.
E to the power 5 equal L1 over D2, D1, sorry, L2, D2, L3, D3.
Yes. Can you solve yourself this one? Because it is solved problem. So what we will do, instead of solving 11.31, we will calculate the equivalent diameter of the problem which we just solved. 11.31 we just solved, right?
Right, doctor.
11.30a we solved. So for that, we will try to calculate the equivalent diameter. Okay. Not this one. Same. See the problem, you just got the discharge. How much is the discharge you got? 0.1108 meter cube per second, right? For the
Right,
same,
doctor.
for the same 2 tanks, instead of 3 pipes, I want to connect by 1 pipe. So can you get the equivalent pipe? Okay. See that 11.31 you can solve yourself because it's the data is already there. So what we will do, we have already solved this problem. Let's just extend this because we are neglecting the minor losses. We can just extend this problem to, we need to calculate the equivalent pipe. Okay, equivalent pipe. Same length, same thing, everything will be same. We need the equivalent diameter. Okay, do you agree with this?
Yes, doctor. I agree.
Now what we have for this problem, we already calculated Q, but we don't need. So L by D5 equals to L1 by D1 5 plus L2 divided by D2 5 plus L3 divided by D3 power 5. Okay. Now, how much is L? Can you tell me what is the L value, total L? 400 plus 200 plus 300, right?
Yes,
It's 900.
900.
Divided by D raised to 5
Equal
equals L1 is 400 divided by D1 is 0.4
to the power 5.
plus
200
D2 is 200
over
0.
0.2 to the power 5 plus 300 over 0.3 to the power 5.
Okay, what is the only unknown? D. This is the equivalent diameter.
0.25 I got.
Zero point 0.2 25 or 3.
2579.
You have taken the fifth root.
Yes, yes, yes.
Okay, you just put x raised to 5 here, right?
Yeah.
Two five seven nine.
Yes.
Doctor, the unit will be in meter, right?
Yes. How much you are getting?
The same number.
Everybody getting same answer?
Yes, doctor. I get the same.
Yeah, doctor. You get the same.
Okay.
Doctor, I have a question.
Yes.
What if I use the diameter on centimeter and on the end or in the end I change it from centimeter to meter? Is it going to be the same answer or not?
Yes, it is going to be same answer, but it is a good habit to convert into meters because that will keep you always in checking what is the
Yes,
unit given.
yes,
If you don't have that habit, then it will be difficult for you later on.
okay, no problem, doctor. Thank you.
Okay, what if you have parallel pipes? Yes, what will happen if you have parallel pipes?
That's my question. I want to ask you what if we have flow and parallel?
What will happen to the discharge? Yes,
Same?
discharge will be divided, right? No, discharge will be divided. It is like branch, right? Branching parallel pipes. If it is coming from one pipe and then going to the two parallel pipes, then discharge will not be equal, but it will be distributed. Total
Okay.
discharge will be equal to discharge at one plus discharge in the other two second pipe. But what will be equal here is the
Velocity.
HF will be equal. Head loss between the equal. Okay, I will directly solve one problem, then you will understand.
Doctor, the screen is off.
Yes, yes. Checking the question to solve. Say this 11.32 question, 11.32. What it is given? A main pipe divides into two parallel pipes, which again forms one pipe, as shown in figure 11.17. But without looking at the figure, can you try that there is a one main pipe. It is divided into two parallel pipes. It is not given that two parallel pipes have the equal diameters or equal velocity. It is not mentioned. So you can have one small and one big diameter pipes. Then again, they are coming to the one main pipe. The length and diameter of the first parallel pipe are 2000 meter and 1 meter respectively, while the length and diameter of the second parallel pipe are 2000 and 0.8 meter respectively. So if you see, the length is same, but the diameters are different. One is having 1 meter diameter, the other one is having 0.8 meter. Find the rate of flow in each parallel pipe. That means Q will be different, because it is asking each parallel pipe means Q will be different simply. If the total flow in the main is 3 meter cube per second. So in the main pipe, that is one pipe, it is the 3 meter cube per second. The coefficient of friction for each parallel pipe is same and equal to 0.005. Now, can you draw the figures? Try yourself. If you commit mistake, no problem, because you are trying yourself. So even if it is going to be wrong, nobody will bother, because you are analyzing yourself that how much you are. So 2001 meter, 2002, 0.8 and 3 meter. Okay, so in case of parallel pipes, remember, in case of parallel pipes, say for example, there is a pipe, main pipe. Now out of this, there are two branches going. One has larger diameter, and the other one has okay. Can you understand this now? If you see this is having diameter 0.8 meter, whereas this has diameter 1 meter. Length of both the pipes is 2000 meter. Is that clear?
Yes.
The discharge The Q is here is 3 meter per second. Meter cube per second. So since the length is same, okay, discharge is going to be, say this is Q1, this is Q2. Q will be equal to Q1 plus Q2. And if you apply at these two locations,
The same.
you go from this, loss is different. Loss is same. The head loss due to friction is going to be
The same.
So HF1 is equal to HF2. 4 F1 L1 V1 square divided by 2G D1 equals to 4 F2 L2 V2 square divided by 2G D2. Can I cancel 4 F1, 4 F2, 2G, 2G?
Yes. And we said that the length is the same.
Yes, length is going to be same. So what it is coming? V1 square is equal to
V2.
D2 V2 square, right?
Yes.
Yes.
Okay. We also know that Q is equal to A1 V1 plus
A2 V2.
because total Q it is A1 V1 plus A2 V2. What is Q? 3 meter per second. Meter cube per second. A1 is pi by 4 D1 square into what is V1?
The square root.
The root of D1 by D2 into V2. Am I right?
Yes.
If I take the square root on both sides here, the square root will go, square will go on, this will come in square root. So V1 equals to under root of D1 over D2 V2, which is here, plus pi by 4 D2 square into V2. What is the only unknown here? D1, D2 is given. Okay, only unknown is V2.
V2.
So parallel pipes is very simple. Can you get V2?
Yes, 1 second.
Yes, everybody following this?
Yes, yes, Victor.
Yes, yes.
I got 5.93.
V2.
Yeah.
Okay. And how much is V1? If you put here, you will get V1.
Okay, wait.
So V2, you got 5 point.
9355.
What?
5.9355.
5.93. Okay. 5.93. And V1. Then you calculate Q1 separately and Q2 separately.
For V1, I got 2.098.
Everybody getting this? Suleiman, Amar,
Doctor, for V2 I got 2.22. I don't know what is my mistake.
You have taken the squares.
Yeah,
Let me check in the book what is the answer. How much you are getting? 2 point?
2.22.
Here in this book it is given 2.17.
Sorry,
2.17.
2.1.
For V2?
Yes. And V1 is 2 point. No, let me check. Let me check. Wait a minute. V2 is not clear here. How much is V1? V1 is coming 2.427 here.
How much? 2.17.
17 is V2. And V1 should be more than V2. So this is, I think you got something wrong, because V1 we are getting equals to under root of D1 over D2 into V2. D1 is more than D2, so V1 should be high.
Could you please show the board again to see?
Yes. See this. V1 equals to D1 over D2. D1 is 1 meter and this is 0.8. So this value will be more than 1. So that means V2 multiplied by more than 1, V1 should be more than V2. So 3 pi by 4 D1 square D1 over D2 V2.
D1 is 0. Oh, D1 is 1?
Yes.
Okay, I wrote 0.1.
No. You are reading mathematics in Arabic from right.
Yeah, 2.17.
Okay, so V2 is coming 2.17 and this will come 2.47, I think. Okay, so we'll stop here. Inshallah, in the next class, we will start our new chapter.
Doctor, I got the same results.
Good.
Okay.
Okay, please try to solve similar problems. I will also provide.
Doctor, this is chapter 4 or chapter 5?
This is chapter 4, right?
Okay.
Because after the dynamics of flow, this is the flow through pipes, laminar, turbulent. Actually, in the book, this is in 3 chapters.
Yeah, in the books,
Yeah, it's
another
11.9.
story. Another story.
Yes, viscous flow, then turbulent flow, and then flow through pipe. So I will combine them and then we'll send you whatever I taught. This chapter.
Okay. Thank you, Doctor.
Okay, see you in the next class.